Good morning, dear children. Now, today we will discuss the phenomena of scattering of light. Now, the word scattering means to change the direction of the light or to spread it out. Now, light will also, they get scattered or they change the direction when they strike with the particles present in the atmosphere. Now, what are the particles present in the atmosphere? Are fog, mist, water droplets, atoms, molecules. All these are the particles which are present in the atmosphere. And this phenomena, the phenomena in which the light, the light rays, they change the direction on striking these particles are called scattering of light. Now, this scattering of light has got plenty of application uses. We see the color of the sky blue when we see from the earth's surface. When we see up, we see the color of the sky blue. That is based on the scattering of light. And also the astronauts or the passengers, okay, when they are flying to the high altitude, they see the sky dark. And also the color of a sun appears yellow, as well as the sunset. During sunset and sunrise, you see the sun reddish. The reddish color of the sun during the sunset and the sunrise is also based on the scattering of light. So plenty of applications are there. So before we come to the application, let us discuss about the factor affecting the scattering of light. Number one factor is the intensity of scattering of light is inversely proportional to the fourth power of wavelength. Okay, and the second factor is the size of the particles. Size of the particles. So these are the two factors in which the scattering of light depends. Now let us discuss the first one. The intensity, that is I, the intensity of the scattering of light is inversely proportional to the fourth power of wavelength. That means, so intensity, the scattering of light is inversely proportional to the wavelength. Okay, shorter the wavelength of light, more the light gets scattered. Okay, shorter the wavelength of light, more the light gets scattered. Or longer the wavelength of light, lesser they get scattered. Since the intensity of the scattering of light, is inversely proportional to the fourth power of wavelength. Which means let us consider 7 different colors: V, I, B, G, Y, O, R. Visual. Now this is the visible light. We call it as visible light. And these are arranged in such a way, so this visual is depending upon the wavelength, increasing wavelength. The shortest wavelength violet has got a shorter wavelength, and even these three colors, violet, indigo, and blue, they are having a shorter wavelength, but the least wavelength is violet. Okay, and the maximum wavelength is having red. So now the shorter wavelength means violet, indigo, blue, especially these three colors. Okay, these three colors has got a shorter wavelength, and the light of shorter wavelength will be scattered more, whereas the light of longer wavelength will be scattered less, which is number one, that is intensity of scattering light is inversely proportional to the fourth power of wavelength. Second one is size of the particles. Okay, size of the particles means that is smaller particles scattered light of shorter wavelength. Okay, the particles can be bigger or smaller. If the particles are smaller, they will scatter the light of shorter wavelength, and the bigger particles will scatter the light of longer wavelength. So these are the factors affecting the scattering of light. Now let us discuss some phenomena or some application of scattering of light. So we can see the color of the sky blue. Now how it happens? Now the light from the sun consists of a white light. And this white light has a mixture of 7 different colors. And when this light rays from the sun, it enters into the earth surface, into the earth atmosphere, especially the three colors, okay, violet, indigo, blue. Okay, all the means all the seven different colors get scattered depending upon the wavelength. Okay, so the larger particles will scatter the light rays of longer wavelength, and the smaller particles will scatter the light rays of shorter wavelength. So depending upon that condition. So almost the shorter wavelength, when the light rays strike with the particles in the atmosphere, the light rays get scattered. Okay, and almost what will happen is that now violet, indigo, blue, okay, all these three are having a shorter wavelength, and especially the violet and indigo will also, all the three colors will scatter, having a shorter wavelength. But then these violet and indigo are not sensitive to our eye to see the color. So now the blue light will scatter, since the blue is also having a shorter wavelength. The blue light gets scattered with the scattered in the atmosphere on striking the particles. So therefore what will happen when the blue light gets scattered, that scattering of blue light will enter in our eyes, and therefore we will see the color of the sky blue. So this is how we can see the color of the sky blue. So this is based on scattering of light. Now second condition is here. Second one, the sky would have been looked dark if the earth had no atmosphere. That means if the earth had no atmosphere or no air, okay, the sky could have become dark. Now how it happens is that if there is no atmosphere on the earth, there could be no particles. Because of the presence of the atmosphere, the particles are there. So if there is no atmosphere in the earth's surface, the particles will not be there. There will be the absence of particles, and the scattering of light could not be possible. So if the scattering of light will not be there, then you will see the sky dark. So therefore the sky would appear dark if the earth do not have atmosphere. Again, the passengers in high altitude, the next phenomena, the passengers in high altitude, they see when they are in high altitude, they see the sky dark. So how do they see the sky dark? Is when we go to the higher altitude, the atmosphere becomes thinner and thinner. That means the air becomes thinner and thinner. So as long as the atmosphere becomes thinner and thinner, the particles will also become less. So when we reach to the higher altitude, okay, the atmosphere is so thin, so there are no particles there, or very less particles, and therefore the scattering of light is not possible. So if the scattering of light will not be there, then the passenger will see the sky will appear dark by the passengers at the higher altitude, and even the astronauts also. Okay, the astronauts, when they go to the space, they see the sky dark, because in the space there is no particles, there is no atmosphere, absence of atmosphere. If there is absence of atmosphere, there are no particles. So scattering of light is not possible. So because of this reason, okay, the passengers will see the sky dark in a high altitude, and even the astronauts also see the sky dark when they go to the higher altitude. Next one is the sun appears yellowish. Now what happens is that now the light from the sun, okay, the 7 different colors, almost the colors get scattered, and especially the light, the wavelength, the light having a shorter wavelength, they get scattered in the atmosphere. Okay, and therefore what will happen is that now the violet, indigo, blue, okay, green. So now green only, so that means least has got a violet. Okay, then little bit a longer wavelength will become indigo. Likewise, blue, then green. So therefore what will happen is that now all the light gets scattered, and this violet, indigo and blue, okay, while scattering, they do not, that means the light coming from the sun, almost all the light gets scattered, especially the violet, indigo, blue will get scattered, okay, much rather than the other light rays, because they have got a shorter wavelength. And these three light rays, when they get scattered in the atmosphere, they are not sensitive. These colors are not, because they scatter much more than the other color. And therefore, this color, and our eye is not sensitive to this color. So therefore, we will see the color of a sun yellow. So this is also one of the phenomena in which the scattering of light, the application, the uses of scattering of light. Similarly, the reddening of sun and the reddening of the sun at the sunset and the sunrise. Okay, so when the sun is at horizon, so this is the horizon. Okay, just below the horizon. Okay, thus when the sun is just below the horizon, the light rays will not enter into the Earth's surface. So when they come up to the horizon, okay, just above the horizon, then what will happen? The light from the sun, they enters into the Earth atmosphere. And when they enters into the Earth atmosphere, all the light will get scattered, especially the red light having a maximum wavelength. Okay, they scatter very least, or they don't get scattered, because the red light will get scattered only striking with the larger particles. So therefore, all other colors will get scattered, and the red will not get scattered into the Earth atmosphere because they are having a longer wavelength, and therefore that red color will enters in our eyes, and therefore we will see the sun red during the sunrise and in the sunset. So all these are the application of scattering of light. So we'll come to the next chapter. We have come to the end of this chapter. Okay, about the term spectrum. Now we'll start with the new chapter, current electricity. Thank you.